diagram is appropriate. What should my diagram look like if I know I'm going to do Hills and SAS? Well, it should be a right triangle, right? The big one should be a right triangle. And then you have to have something drawn inside that right triangle. And that something is an altitude from the right angle to the hypotenuse. The diagram has to look like, maybe it'll be rotated, I don't know, but it has to look like that for you to use Hills SAS. Anything else, it's going to be one of the other topics. So let me label the vertices, and you guys tell me how this Hills SAS business works, because it's been a while. First, let's start with Hills. Here's what I want as I call on you. I want to know what the letter stands for and where is it on the name it on the diagram. Segment, you name it. All right. So let's first start out. What does the H stand for in Hills, and where is it on my diagram? What's the H stand for, and where is it? 1's not here. 6. Alyssa, what's the H stand for? And where is it on the diagram? Name it.
Nope. BD.
Good. Good catch. Good catch. There it is. BD. That's your hypotenuse that you use in Hills. All right. L. What's my L here? Stands for, Simon?
Leg.
Leg. Now, we could use one or two depending on what's given in the problem. Name both legs.
AD or AB.
Yep. It could be AD I'm using, or it could be BA. Follow-up question. I go to the other L. Do I use the same leg I'm on, or the different one?
Different one. Or same.
Same. Means are always the same. The L's and Hills are the same. All good. S for 16. Bryson.
Segment.
Segment. Name them.
BC.
Or
CD.
or CD. Follow-up question. I'm using leg AD in Hills. So AD and AD. What segment do I want then? I'm using leg AD, so I can't just pick either one. I got to use a specific one.
CD.
CD, the one next to the leg. Everyone go on Hills. You got to use the segment next to the leg. All right, let's roll with SAS now. The S in SAS. 17. Dylan. Segment. Now let me go to the other S, Dylan, while I'm here with you. That's segment. Now, are these the same segments or different ones? Different. Segments are different in SAS because they're the extremes too. And how about the A in SAS? The A for Drew? Altitude. I haven't labeled it. Where is it? AC. Good. Same altitude or different? Same. There's only one. Right? And they're the means. All right. We all good? Hills and SAS. Got to be that diagram. All right. Altitude drawn to the hypotenuse. Has to be. All right. Pythag. Hey, this could come up in any problem. All right. Hey, it might be a 30, 60, 90 or a 45, 45, and you could still use Pythag if you have 2 out of 3 sides, right? Got to have 2 out of 3 sides. This is a right triangle only. All right, what if I do this to you tomorrow? I give you 3 sides of a triangle. You plug it into Pythag, and this is what happens. A squared and B squared come out to be less than the C squared value. So C squared is bigger. What type of triangle is this? Because it's not right anymore. Is it an acute or obtuse triangle if the C squared is bigger than the other 2? So you do the 2 smaller sides squared, and then you do the biggest side squared, and what type of triangle is this one? C squared's bigger. Good thing we're reviewing, Dylan.
Obtuse.
It is obtuse, yep. And then if the reverse happens, where the C squared value is now smaller, now it's acute. Okay, be ready. Be ready. Questions there? All right, let's review our rules now for our special triangles for tomorrow. What do you know? Give me some fact about that triangle. You know it's 45, 45, 90. Give me a fact about it. Special fact about it. Alexi.
The 2 angles are congruent.
Thank you. They're both 45.
Yeah.
How about the sides?
Oh, the sides are congruent.
All of them?
No, just the legs.
Now, here we go. Yep, let's use our vocab. Legs congruent. Good. And then how about something about the hypotenuse? 10, Henry, what about the hypotenuse? Good. Leg, and make sure it's radical 2. Don't stick the radical 3. That's coming up. This is radical 2. Good work. And then how about the next one? 30, 60, 90. We should know how to find the hypotenuse from yesterday and the longer leg. So either one, you tell me which one you want. Two, Bailey, which one you want to find? Just one rule. I don't care.
Okay, the hypotenuse
Which
is
had-
2 times the small side.
2 times the,
Smaller leg,
and how do I find that? That's the one across from
30 degrees.
30. Good. 2 times shorter leg, which is always across from the 30. Good. How do you find the longer leg now? Longer leg up here, 6. Alyssa, back to you.
Short leg 10. So
Radical 3. Perfect. Now, how do you find the shorter leg? Oh, I'll probably give you the hypotenuse or longer leg. You substitute it in and solve for the shorter leg now. Right? You need to find the shorter leg. And then I just have 2 reminders for you as far as your calculator goes, and also another reminder about rounding. So let's say tomorrow, it's not going to be like this. This is way too easy, but I give you this and I want you to find the hypotenuse, right? So it's Pythagorean theorem. So you say 8 squared plus, here's what I want to remind you about. What are you going to type into your calculator now? Parentheses, 8 radical 3 squared. If you do not have the parentheses on there, your calculator is going to think you want to square just the radical 3, which I do not. So I want to square the whole thing. All right, so make sure if you're dealing with Pythagorean radicals, you put it in parentheses tomorrow. Final thing, if there's rounding directions tomorrow, nearest tenth, nearest whole number, nearest hundredth, whatever the rounding directions are, when do we round? At the end of the problem. Do not round numbers mid-problem, all right? So round at the end of a problem. Do not do it halfway in between and then you start rounding. Write the full calculator display out. Questions? Okay, go to day 6 now for me in your packet. Let's talk. Before we get going, I'm only going to do 2 problems with you, and I'm going to let you do the rest on your own. Before we do that, though, here we go. Where are all the practice problems located? Well, you have some right there in day 6. Everyone see at the top? You guys have textbook questions to try. There's practice questions there. And take a peek up here, please. Up on Classroom, under Unit 8, you'll see extra quiz 1 extra review. This contains, ready, Hills SAS. These are all Hills SAS questions. If you're struggling with those and want to get some extra practice, you keep going. 45, 45, 90, 30, 60, 90 questions. And our favorite at the end, the double triangles. All right, because I know those are tough. So this is all on Classroom for you guys to try. So you have day 6, textbook questions, extra review on Classroom to try. All right. First grade, 3rd quarter, 2nd semester, Unit 8. Some of you guys are doing great. How about just some of you guys, let's not be happy with 70s anymore. All right, let's fix it. Let's start putting in the work we need to put in. All right, some of you guys keep working keep doing the work that you do because you're doing great. How about we just change your act, some of you? That'd be great. You get a fresh slate tomorrow. Fresh slate to do this. All right, let's stop being happy with the 70s that we get. All right, if you need to come in after school, you come in after school. It doesn't need to be the full time, 10, 15 minutes, whatever. All right, but let's get this done tomorrow. All right, any questions? All right, take a look at number 1. I'm going to do 2 problems with you in the packet. Number 1. Stop being satisfied with mediocrity. Number 1, fill it in. Go ahead. I give you some values. Let's fill it in. And then we'll talk. Here's what I would love for you to do tomorrow. Fill out your diagram just like we did. Take a breather, and then say, all right, what type of problem is this? Because it's got to be one of four. Hill-SAS, is it a Pythag, is it a 45-45 or 30-60? So take a breath after you've written all your numbers down, all your lengths, whatever you got to fill in the diagram, and ask yourself, what type of problem is this? All right, at least win that competition first before you figure out what the answer is. Now, does anybody see any, other than the right angles, anybody see any other degree measures written in? Me neither. So why am I getting so fired up? Don't put in degree measures. You don't know. I do not want this to turn into, oh, ha, 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 this is 45. I'll make this a 45-45. No, you don't. All right, you don't. If you can't mathematically show yourself tomorrow on the quiz that that's a 45-45 or 30-60, don't write it down. Don't write it down. All right, unless I put congruent marks or anything else, you don't know if that's 45 or 30-60 at all. So don't write it. That just shows me we're getting desperate and we didn't practice at all. What type of problem is this? Look at the diagram. We just talked about this, right? Right triangle, altitude to the hypotenuse. This is Hill-SAS right off the bat. Has everyone identified this is Hill-SAS? All right, so you identified it's Hill-SAS tomorrow on the quiz. Next thing, what am I asking for? What is that? That's called an altitude. So it comes to mind, the only one that has altitude in it is SAS. Look how we're breaking this down. And then you look at it and you're like, wait a second. It's got to be a SAS, but I don't have anything for the segments, do I? Okay, well, I guess I can't use SAS right now. But is there anything else that has segments in it that maybe could help me find the segment? Yeah, it's what? I actually have to use hills here first, and then I'll get back to SAS. Does everyone see our plan now? You can't. Yes, we are going to use SAS for the final answer. You don't have enough information, so to find that information, we're going to hills. All right, your guys are up now. Help me fill in the hills here. Hypotenuse. Whew. What's my hypotenuse length in this diagram? Ooh, Stephanie, what's good? 6, good work. Leg, you get a choice now. You tell me what leg we want to use here. 6, Alyssa, leg? 3.6. So if we use 3.6, we better use it again. Don't use 4.8 in the other L. We don't know what's going on with hills then. There's 3.6. Now that tells me if Alyssa wants to use 3.6, she'll be finding segment AR. That's the segment we're finding if we're using 3.6 for the leg, because it's always the segment adjacent. All right, go ahead, cross them up. We don't round anything to the end either. Keep that full. I don't know how long it's going to be, but keep that full calculator display. And what do we get for that segment length? That segment length, 20. Brendan, what do you have?
12.96.
12.96?
Oh,
Yep, one job.
2.16.
There you go. Looks a little better. 2.16. So everyone's good. Why 2.16? All right. I still can't go back to SAS, right? Because the S's in SAS are two different segments. So I still need RF. Now, you could go back and do hills again. And instead of 3.6, use 4.8. Can I get there quicker, though? I don't need to use it. You can, but I don't need to use it. How about 6 minus 2.16? That'll get me there a little quicker. Or again, if you want to do hills again and substitute in 4.8 for the legs, go ahead. What is that, by the way? What's RF going to end up being? 3.84? There we go. So I used hills to find both segments. Now let's head back. Go ahead, head back to SAS. I got it now. 2.16 over altitude equals altitude over other segment, 3.84. Don't round until the end. Period 2906. All right. And what do we get for that altitude length in SAS? Shoom, Stellan, when you're ready.
2.88.
Yep. 2.88. Take a label your diagram, take a breather, figure out what type of problem it is tomorrow. Because it only can be one of 4 types. Only one of 4. Questions? Now, hey, just going back, some of you guys can once I found that 2.16, I could have done Pythag on that right triangle too. All right, so always remember Pythag tomorrow if you get stuck. You have Pythag available. And the other one I'm going to do with you is on the next page with the box of chocolates, number 4. And I won't do this to you tomorrow. It won't be this difficult because we do need something pre-midterm to get this thing started. So I won't do that to you tomorrow, but it still covers one of our topics here. So I got a hexagon inside a rectangle. And I tell you, if the length of the hexagon is 3 inches, and somebody asked in the other class, well, does that mean that one side is 3? Regular, right? So that means it's all 3. I don't need to label them, but that means that they're all 3. I think I could put one other marking confidently here. So what type of box? Rectangular. So what can we put at the corners here? Yeah, right angle. So this is where the right triangles come into play. And so we're all clear on the directions. When I ask for the dimensions, I want to know what's the length and the width here. So I'm looking for this here and this here. What's the length and the width? That's what I need your help on. All right, that's what I need your help on. So everyone good on what I've already labeled before I go pre-midterm on you here and talk about another topic? All right, I got a right triangle. I can't do much right now, right? No Pythag, no 30-60, no 45. We're not going to throw something in unless we're confident. All right, so let's become confident now. You guys remember 1, 2, 3, 4, 5, 6. What's that type of angle called on the outside again? Exterior, right? If I drew all 6 in, do we remember what they add up to? Oh, 360, right? So can you find one of those? Take 360 and divide it by how many sides here in my hexagon? 6. Go ahead, find one of those exterior angles. And it'll be a nice little number we're familiar with, huh? 60. Now, why am I having you find that? Everyone see the exterior angle in the diagram now. Apply it to the diagram right here. 60 degrees. Now, what type of problem? Now, if you go one of the 4 types, what type of problem is this? 30, 60, 90 now. Okay, it's 30, 60, 90. And there's your 30. All right, let's do this now. Let's get to work. What's the 3? Now I'm going to start asking you guys questions. Now you guys should roll now. What's the 3? Longer, shorter, hypotenuse. What is it in my 30, 60, 90? 14, Stephanie, what's the 3 acting as? Okay, everyone, here you go. Write it. Hypotenuse equals. What's my rule? 30, 60, 90. Hypotenuse equals. True, and Bryson.
2 times the shorter leg.
Okay, here we go. Substitute in. Substitute in 3 for the hypotenuse. What is the shorter leg going to be then? What is my shorter leg going to be in that 30, 60, 90? Solve for the shorter leg. Shorter leg will be how long? When you're ready, ones. Yeah, D1, Zoli.
The shorter leg will be
1.5. 1.5, good. And that is across from the 30. So everyone, here you go. That's 1.5. How about the longer leg now? Because I still need the side across from 60. Longer leg. What's the rule before we find it? Rule. Not here. For test, what's my rule for longer leg?
Shorter leg times radical 3.
Good job. So my longer leg across from the 60 is going to be 1.5. Radical 3. I don't need any decimals. All right, we're ready to find the length and the width now because we have all the information we need. Let's find y first. I call that the length. I don't know, maybe some of you might call it the width. I call it the length. I got 1.5 here. How long is this piece going to be up here? Also, I don't need to do this 30, 60, 90 business again. It's also going to be 1.5, radical 3, add them together. How about the length? 1, 3. Jonathan, when you add those two together?
3 radical 6.
3 radical, I don't know if it's 6 or not.
Oh, 9.
Oh, I don't think it's 9 either. 1.5 radical 3 plus 1.5 radical 3.
Oh, 2 radical 3.
What are you typing in your calculator? 1.5 radical 3 plus 1.5 radical 3, right?
Yeah. Just do like this.
You're doing, do 1.5, but it's not 1.5 radical 3, get that plus 1.5 radical 3. Still giving you.
Yeah.
Okay. Oh. Has anybody's given them just the, oh, there you go. Now highlight it, see what it gives you.
Oh,
There you go. Okay. So if that happens, just highlight the decimal. It'll tell you what it is. 3 radical 3. All right. What about x now? How can we find the width? All right, I don't want to know the answer. I just want your help with it. With your help. Here we go, Alyssa. I got the 1.5. How about this side right here?
Give me 3.
That's 3. And then what about this little piece left over here?
5.
That'll be 1.5. Good. Add them all up. What do you got for me? Yeah, let's keep rolling. 6. There you go. Now, again, I wouldn't give you this type of problem. I would give you this type of problem tomorrow, but I would probably spot you the 60 first. I'd give you the 60. I wouldn't have you find it. But absolutely, I would give you this problem and say that's a 60, so you knew it was a 30, 60, 90. Right? Definitely. Okay, you got 3 places you can go. If you can finish the day 6 examples, you can go to the textbook, which is on Classroom, or you can go to the extra review, also on Classroom. Everyone, get your Chromebooks out. Get the answer key out if you're starting with the packet. All right, it drives me nuts when you guys do problems and you don't know if you're right or wrong.